Good morning, ladies and gentlemen. Here's the video for 9D. Kind of a lot here. Make sure that we are paying attention to this because this will sort of really help us when we get into this tomorrow. So it's exponential function here. So suppose we had $100 in a savings account that grew by 12% per year, right? So we know exponential functions. We have a times b to the x power, right? A is sort of what we start with. Okay, b is our multiplier. Okay, whether we grow or decay. Okay, and x is our number of repetitions basically. All right. For this one, we're just going to change the x to t because we're talking about time. So if I use t, it's just the same as x. Okay. So if we had an exponential function like this, you put $100 in a savings account that paid 12% per year, the formula would be, well, we start with our a value of 100. All right. We grow by 12% per year. All right. So again, 12% growth, so we're going to add 1 plus 0.12, which is equal to 1.12. Okay. And then however many years is going to be our exponent. All right. Again, so if we grow by 12% per year, what we do is we multiply by 112%. We talked about that early this past week. All right. So pretty simple concept. Hopefully we understand that. But now we're going to add another layer to this. This is going to be the same formula, but the way it's sort of sliced up is going to add a few wrinkles to it. So hopefully we're ready. So pause the video if you need to, get this down, rewatch it if you need to. All right. So say we had $100 in an account that paid 12% per year, compounded monthly, okay? So compounded monthly, 12% per year compounded monthly, it's a little bit different, okay? And so we need to sort of slice up the formula accordingly. So compounded monthly means the 12% is split up each month. Okay, so that 12% is split up each month. So instead of getting 12% at the end of the year, we divide those percents up per month. Well, okay, simple. There are 12 months in a year, okay? 12% divided by 12 months is 1%. Okay? The interest formula still uses years for t, all right? So in this scenario, we're going to be earning 1% every month, which is going to be 12 times per year. Okay, so how this is going to sort of look is now, okay, we still start with our $100. All right, well now we're adding 1% per month. Okay, but if t is still in years, what we need to do is we need to multiply 12 with t. All right, because if we for 1 year, if we put 1 in for t, what we're really getting is we're getting 1% 12 times, okay, because 12 months in a year. Okay, so the b number changes a little bit. Okay, so now it's 1.01 because we're getting 1% per month, and our exponent changes. Instead of t, it's going to be 12t because there's 12 months in a year. So the formula is going to look a little bit different. All right, pause the video if you need to. Again, this little thing right here sort of explains everything. All right, say we had $100 in an account that paid 12% per year, compounded quarterly, okay? So 12% compounded quarterly, okay, so quarters, there's 4 quarters in a year, right? So the 12% is split into 4 quarters. So if the 12% is split into 4 quarters, what we're really getting is we're going to get 3% per quarter, because 12 divided by 4 is 3. Okay, our A value is still the same. We still have 100. Okay, now we're gaining 3% per quarter. So we multiply by 1.03. All right, there's 4 quarters in a year, so we're going to multiply 4 times our T right there. Okay, so if we go for 1 year, okay, let's just say we go for 1 year, right? And we get 3% per quarter. All right, so now we have 100 times 1.03, all right, to the 4th power, because T is equal to 1. And we do, we multiply by 1.03, 1.03, 1.03. Just as a quick little example right there. If we went semi-annually, so semi-annually, okay, there's 2 halves of a year, right? So semi-annually means that 12% is split into 2 times per year. So what that means is 6% twice a year. All right. So we start off with our 100. All right, the 12% is split, so we get 6%, so that's going to be 1.06. All right, semi-annually, so there's 2 semi-years in a year. So that'll be raised to the 2t power. Again, t is always our years. All right, if we did this daily, okay, if we compounded this thing daily, which is every day, all right, so what we have here is, so there's daily, so there's 365 days per year. So the 12% is split into 365 pieces, okay? So if we take that 12% and divide it by 365, so if we do 0.12 divided by 365, all right, we get something really low, so we get 0.00033 approximately. Let's round it to that. Okay, so now we have our original 100, 1.00033, right? It's compounded daily, 365 days a year, so we have to multiply 365 times t in the exponent right there, okay? So basically what we're doing is we're getting a much smaller percentage, okay? So this is our smaller percentage. $365 times per year. So here's a formula if we have a compound interest. Again, going back to our thing here, we have y is equal to ab to the x power, okay? So the a doesn't really change, okay, except we're going to change this. The A is going to become P. All right. So the A is going to become P, and the X is going to, of course, become T. Right? And we're going to have to mess around a little bit with our B. Okay? The B is going to become 1 plus our rate divided by our number of compounds. Okay? So the A becomes P, the B becomes 1 plus R over N, and the X becomes T. So why don't I redraw it like this? And of course, we're going to attach an N to the T for our number of compounds right there. All right. So the formula, P, 1 plus R over N to the power of N times T. All right. P is our principal. R is our rate. T is still the number of years. I need to erase this thing so I can scroll down. So pause the video right now if you need to still copy this down. So P is our principal, R is our rate, T is still our number of years. The new variable N is the number of times per year that the money is compounded, okay? So if it's, you know, semi-annually, N is 2. If it's quarterly, N equals 4. There's 4 quarters in a year. Okay, if it's monthly, N equals 12 because there's 12 months in a year. It's weekly, N equals 52 because there's 52 weeks in a year. All right, if it's daily, N is equal to 365 because there's 365 days in a year. We'll look at these example problems tomorrow. Let me just give you the next part of the notes, and we'll do the example problems when we come back tomorrow. Okay, continuous compounding. All right, if we have $1 and we get 100% interest rate for 1 year, a function that shows how many dollars compounded. Why do we have that? I don't know. So no. Okay, so let's talk. Right. So y equals p r plus, or 1 plus r over n to the nt power, right? And so if our p is 1, 100% interest rate, all right, so something like that. Now, if we know that the more we compound our interest rate, the more money we end with, there's a limit. All right, that's 1. I'm going to jump down to the formula. I put some stuff in here that I shouldn't have. Let me just write this down and then we'll be good. We'll be good. All right. The number that it approaches is called E, which is about 2.718. If you type it in your calculator, it ends up just, if you type E in Desmos, it automatically gives you that. So if we talk about interest being compounded continuously, all right, if it's compounded continuously, we know our n is infinity, and we can't use, you know, our compound interest formula like that. All right, because we can't do 1 plus r over infinity to the infinity times t power, because you can't plug infinity to the calculator. So you can't do that, okay? So we replace the formula with this, okay? If only for continuous, only for continuous, only for continuous, we have y equals p e to the r times t power. So if the thing compounds continuously, we replace that with p times e to the rt power. Pause the video if you need to. All right, so if the problem involves growth, r is positive, only with this continuous thing. If it involves decay, the r is negative. In word problems, the r may be replaced with k, but it's the same variable. So let me just give you 2 example problems here real quick, and then we'll be on our way. So again, this is continuous compounding. So continuous compounding, we need to do the PERT formula. All right. So on these, y equals PE to the RT power. All right, he has $1,200, puts into account that pays 6% interest compounded continuously. How much money will he have after 20 years? So 1,200 is our P. E. 6% is 0.06. And we multiply that by 20 in the exponent. We just type it in the calculator just like that. So we have 1,200 E, and we're going to raise it to the power of 0.06 times 20. We should end up with 3984.14. All right. Same thing with decay, but we remember what I've said before. Decay is going to have a negative interest rate. So if we're looking at this one here, $50,000 truck, multiplied by E, which you can type right into the calculator. It depreciates at 12% per year, so we're going to multiply by negative 0.12 times 8 in the exponent. And so the value of our truck, if it does that, $19,144.64. I know that's a lot. Make sure we get this copy down. We'll talk about this more when we come back Thursday and Friday. And we'll sort of square it all away from there. Thank you guys, and you all have a good day.